Alright, so today we're going to talk about solving systems of inequalities. So the difference between an inequality and an equation is the sign. So remember, inequalities are like the greater than, less than, greater than, or equal to, less than, or equal to signs, okay? So they're a little different when we talk about systems because we have to deal with the fact that there's infinite solutions to an inequality versus an equation only has one solution. So before we start that, because inequalities, you must graph them, we're going to review a little bit about slope and y-intercept, because I know you're a little confused on that from the video the other day. So, slope and y-intercept. So here we have a picture of a mountain, right? A mountain helps us to think about slope. So when we're talking about slope, I have to get my pen turned on. Our slope is our rise over run. So remember, slope is equal to the change in y over the change in x, meaning y2 minus y1 over x2 minus x1. We also say that this is equal to m is slope, and we say that it's rise over run. Okay, so if I look at this mountain, if I'm climbing a mountain, the slope of the mountain is this right here. Alright, that's my slope. Going up a mountain, I have positive slope. I'm climbing, it's positive, and then I get to the top of the mountain, and it's a flat slope. Okay, that would be no slope, or zero slope. Alright, then going back down the mountain is negative slope. Alright, so if you think about slope in that, you have to rise up on the mountain before you can go back down. So when we talk about rise over run, if you think about the rise of the mountain is what you want to do first, then you want to go across the mountain, and then that's rise over run. So up and then across. Alright, you don't want to run around the base of the mountain first. That would take a really long time. You want to climb up first and then go to the right or left. Okay, so this is the rise, this is the run. I hope that kind of makes a little bit more sense. So if you think about it in terms of mountain, uphill is positive slope, downhill negative slope. We want to rise the mountain first and then run around the top of it, which is smaller, before we run across the mountain on the bottom and then go up. That would take a lot of effort. Okay, so think about it kind of like that if you need to. I hope that's a good analogy. If it's not, then just ignore me and we'll keep going. Alright, so when we're doing inequalities, there's 5 steps to doing inequalities. You have to graph inequalities. Okay, because the solution to inequality, let's say we had a line like this and a line like this, the solution is a shaded region, meaning that the multiple answers would solve the system of inequalities. So the first thing you have to do is determine slope and y-intercept of one of the equations, because we want to graph that first. So we want to find slope, y-intercept where it crosses the y-axis. Then we want to determine if it's a dotted or a solid line. So say we have greater than or less than. Because there's no equal to, these are what we call dotted lines. So we would graph it with a dotted line. We also have greater than and equal to, less than or equal to. The equal to shows you that it's going to be a solid line when we graph it. Okay? So if there's an extra line on the bottom, it's a solid line. Then we have to decide, do we shade above it or do we shade below it? So if I had y is greater than x, I would shade above it because y is bigger than the x values. Okay, so greater than, you shade above the slope. If I say that y is less than x, meaning that all my y values are smaller than the x, I'm going to shade below it. Now the trick to this is, if I have the coordinates here, and you'll have, ideally there's arrows. Okay, x is here, y is here. So, if I have a greater than, I'm going to shade to the greater y. If I have a less than sign, I'm going to shade to the lower y, because these are negative, these are positive. So if the equation is greater than, you're shading towards this up arrow. If it's less than, you're shading to the bottom arrow. Alright, then you graph the second line, you make the same decision, shade above, below, and then where the intersection of shading is, that is the solution set of the inequality. So you don't have just one intersection point, you have an entire graphing area. Alright, so let's do an example of that. So before we can even do that, we have to find slope and y-intercept. Well, this isn't set up to do that, so we'd have to move things first. So that first equation x plus 2y is less than 2. I want to get the y by itself, so I'm going to subtract the x. So I get 2y is less than 2 minus x. Divide everything by 2. So my first equation would be y is less than, I'm going to say, negative 1/2 x plus 1, because 2 divided by 2 is 1. Alright, so I'm going to graph this one first. Looking at this problem, it's less than, means I'm going to shade below it. It's not equal to, so I'm going to have a dotted line. So I'm going to go ahead and go over here and graph it. So I'm going to go up 1 and put a dot. Then I'm going to go down 1 to the right 2, because it's a negative slope. Down 1, right 2. Down 1, right 2. Okay, same thing, you go up and to the left 2, up and to the left 2. Now because it's less than, I'm going to do a dotted line. So I'm going to draw it like this. Ooh, I shouldn't have put, sorry. Go back. It's going to be dotted like this. Okay? And yeah, it's pretty awful because of my pen. And then it's less than, so I'm going to shade to the less than arrow, so all of this would be shaded in. When we do this in class tomorrow, you can use 2 different colors. So I'm going to use 2 different colors. So let's change the color of my pen. We'll use blue. So that's the first equation, this one. Let's do the second equation. So I would have to, I'm going to go ahead and just move the 3x because I'm running out of space. So I would have y is less than or equal to negative 3x plus 3. Alright, all I did was put the x in the front. And there's nothing to divide by because it's not there. So my less than or equal to means I'm going to shade below the line. It means that there's going to be a solid line. And so now I'm ready to graph. So I'm going to go over here. I'm going to go up 3 and put a dot. Alright, it's negative 3, so I'm going to go down 1, 2, 3 over 1. 1, 2, 3 over 1. Vice versa, I can go up 3 and over 1. Up 3 over 1. And like I said, it's now a solid line, so it's going to be solid. Okay, it's less than or equal to, meaning I'm shading below it, so then I'm shading here. Alright, now you don't really want to shade above the other line because it already told you that's not a part of the solution. So this shaded region here, all right here, is where any of those answers would work for this system. So you can pick one. So say I picked negative 1, negative 1. I can plug it in up here. If I say negative 1, negative 1, well, negative 1 plus a negative 2 would be negative 3, which is less than 2, so that works. If I plug in a negative 1 here, negative 1 here, 3 times negative 1 is negative 3. Minus 1 would be negative 4, which is less than or equal to 3, so that works. Okay, so you can test your points. So you want to test points to make sure it works. To make sure you shade it correctly. I'm running out. Shaded correct. Alright, so make sure you write that down. You want to test a point at the end. So to review, and yes, I know it's super messy, we first got it to y equals mx plus b. That's your first step. Y equals, or y is less than or equal to whatever, mx plus b. Then we drew the first line shaded, drew the second line shaded, and there they intersect is the solution. Alright, there's one more thing we need to talk about. So let's go here. Let's insert a new slide. Sorry, my computer is super slow because it just is. Is it not going to do it? Insert. Next slide. Click. Why won't I do it? Where's my mouse? Insert. Home. Layout. New slide. Blank slide. Alright. So, solutions to inequalities. Solutions. Alright, you're looking for where the shading intersects. Alright, but we have to talk about this. So if I have a dotted line and a solid line, and say my shading was here, this point right here is not a solution because it's not included on this dotted line. So when it's a dotted line, it means that it's not a solution. Like none of the points on the line count as a solution, but instead everything below or above it. Alright? If we had two lines that look like this, and it really doesn't matter about the shading, we're talking about the intersection point of the lines. So if it was shaded up here, that'd be okay. Because both lines are solid, this is a solution. Okay, so in order for the coordinate where they intersect to be a solution, they both have to be solid lines. So if we had two dotted lines like this, and shading over here, this point is not a solution. Alright, so they have to have, the solutions has to be where the shading intersects, and in order for it to be the exact point where they cross, they have to be both solid lines. Alright, this should be a review from Algebra 1. If you're a little bit confused, go back and rewatch the video. Hopefully you have a little bit more sense of what N and what B is, but we are going to practice this tomorrow in class, graphing inequalities, which will help you with just your overall graphing skills. Okay, but to recap, back to the first slide, remember slope is the change in y over the change in x. That's why we do rise over run. Then to solve them, we want to get it into y equals mx plus b. Okay, we want to determine if it's dotted or solid. So if it's less than or greater than, it's just dotted. Less than or equal to, greater than or equal to, it's solid. This is a line. Okay, we want to graph the line and shade either above or below depending on the sign of the inequality. And then you want to do it for the same one. Okay, then remember that solutions, in order for the coordinate where they intersect, this is the difference between an inequality and an equation. In order for the coordinate to be a solution, it has to be two solid lines. Otherwise, you have to pick a point within the shaded region. Alright, so this was lesson 1.4. I hope you took notes. If you didn't take notes, you need to rewatch the video, take more notes, or take notes. This should go under your notes section 1.4. Tomorrow we will be practicing this in class, so if you do have questions, make sure you put them on the WSQ and I'll answer them first thing tomorrow. Alright, have a great night. I'm glad that you watched the video.